Every technology begins with an idea. Maybe it gets sketched on a napkin, written in a journal, or just kept tucked away for years. Here's an Idea looks at the creators who've spent years in the garage, in the lab, and in the field, working to bring their designs to life. In this podcast series, we speak with industry insiders and the inventors themselves, exploring the inspiration behind some of today's most innovative technologies. So, here's an idea. 3D printing. Have you heard of stereolithography? How about additive manufacturing? Chances are you probably heard of 3D printing. These are all names that describe the modern fabrication process that's being used everywhere today, to make everything from football cleats and jet parts to prosthetics and dental implants, to jewelry and even selfies. Just this month, researchers from MIT used a robotics system to create the framework of an entire building in less than 14 hours. A team from Germany recently presented a new way to 3D print glass into special structures, including eyeglasses and laptop cameras.
So one of the most bizarre examples is a woman who passed away, was cremated, and they used her ash as the feedstock for the 3D printer.
This is Terry Wohlers. He has studied the 3D printing and additive manufacturing market for 30 years.
And they built a toaster out of grandma. Crazy. And I have pictures of it. It's really a very strange application, but yeah, it was done.
Terry is the president of an independent consulting firm, Wohlers Associates, which publishes reports on the state of the 3D printing industry, current applications, and the technology's future.
I got to say this, I've never had so much fun in this business. I tend to work a lot because I like it so much. It's contagious. You know, it cuts across so many different areas, from bioprinting to aerospace parts, automotive, electronics, consumer products, and I'm really referring to things like eyewear, footwear. I'm looking at some 3D printed faucets here, some bathroom, kitchen faucets. It's a great time to be part of product development and manufacturing, because we're seeing a lot of new different types of products and businesses that are coming about as a result of this.
In this episode, we'll look at how 3D printing began, and how even the inventor of the 3D printer himself could never have guessed that his technology could be capable of producing so much more. The basis of most 3D printing today is a process called stereolithography. Stereolithography relies upon a kind of acrylic-based material known as a photopolymer. When an ultraviolet or UV laser beam strikes the liquid photopolymer, the light-exposed material instantly turns into solid plastic, creating a layer of a specific 3D model design.
The concept of 3D printing is to additively build up thin layers in a material or some materials.
This is Chuck Hull, co-founder, executive vice president, and chief technology officer of 3D Systems, headquartered in Rock Hill, South Carolina. He invented the 3D printer, or as he called it at the time, the stereolithography apparatus.
So layer by layer, you take the data, build the layer, build the next layer, and adhere it to the one before it, and so forth. When you finally get done adding up all the layers, you have the part that you're building. So almost all 3D printing is based on that even today.
Back in the early 1980s, Chuck was trying to come up with a way to more rapidly prototype plastic parts that were going to be injection molded.
The process was very time-consuming between when you had an idea for a plastic part and when you had the first article in your hand. So you had to design the part. Typically, we even used blueprints back then, not computer design. Got the design, then went to a tool designer, design a tool so that could be molded. Then a tool maker who made the tool, and finally an injection molder who put it in and ran a few samples for you. So depending on a part, this could be 6 weeks, even longer before you saw the first part. And you usually whenever you get the first part, you always find the problems with it, so you kind of have to start the cycle over again. So it was very tedious.
At the time, Hull was working for a small California company that used UV light to turn liquid polymers into hardened or cured coatings.
I had seen UV curable materials in thin layers for coatings and inks and so forth, and I had thought, maybe that's a piece of plastic. Maybe we could figure out some way to prototype plastic parts with it.
With the company's permission, he was allowed to pursue his idea of using the polymers for rapid prototyping.
This was all working nights and weekends, in a little lab the company said I could do that in. So it was gathering up the parts, putting together the experiments, going through, 100 things that did not work, and then finally getting to what looked like it worked.
And when did you realize that you could make a living doing this?
My concept was to innovate, come up with something like a 3D printer, and then that company, we would all develop it. We would get the funding, we would develop it, and that would be part of my job at that company. But the president of the company, when I told him how many dollars and engineers and time it was going to take to commercialize this, said, "No, I really don't have the funds to do that." I had, in the meantime, been studying entrepreneurship off at Caltech, and I said, "Okay, how about I'll do a spin-out company? I'll take this idea I just developed, I'll license it back from you, and start a new company." And that's kind of when I got the inkling, okay, I somehow have to make money out of this.
The 3D printing market has changed, according to Terry Wohlers, even within the past 5 years. In 2011, only 31 manufacturers of industrial-grade 3D printers existed. Fast forward to 2015, there were 62. At the end of last year, the Wohlers Group counted 97 companies worldwide producing and selling the high-end machines. 3D printers have found roles now in automotive plants, emergency rooms, and even in space, as NASA placed its own additive manufacturing device on the International Space Station in 2016. And it's not just plastic parts being printed. Many organizations around the world are trying to print both hard and soft tissue that can be implanted into animals and humans.
The idea is to someday, if you lose a finger or damaged liver or heart or whatever, that you could remove cells, living cells, out of the patient and then use those to produce the replacement part. Someday, perhaps in our lifetime, we'll be able to benefit from that application.
We may not have to wait that long. Take the work being done at Northwestern University. Professor Ramille Shah and a team of scientists have 3D printed an ovary.
This is the first 3D printed artificial scaffold with follicles that has resulted in recovery of hormone function in a mouse model, as well as led to live birth.
The team's synthetic ovary is made up of a 3D printed scaffold, or skeleton, that the scientists filled with actual ovarian follicles from mice. The researchers removed a mouse's ovaries and replaced them with their new hormone-producing bioprosthetic ovaries. The end result? The birth of healthy mouse pups.
So the follicles are the cell aggregates where you have the egg, but surrounding that egg are these hormone-producing cells, and that maintains follicle function, survival, and it produces the natural hormones that a woman needs throughout her lifetime.
So the bioprosthetic ovary is ultimately a combination of the 3D printed scaffold and the follicle. The scaffold platform is essential in its ability to allow the ovarian follicles to survive and function, as Ramille Shah and her team discovered.
The discovery was on two levels, more on a basic science level, where we did show that architecture does significantly influence how these follicles interact with the material. It affects their viability and also function. And then on a more grander scale, we showed that the optimal architecture with those follicles was able to be implanted in a mouse and led to the recovery of normal hormone function and live birth in a sterilized mouse.
Now, whether you're using a 3D printer to create a plastic part or a body part, the application will require the right material. The ink that Ramille Shah and her Northwestern colleagues used, however, was surprisingly simple.
Interestingly, it was just gelatin. There were no additives that were necessary. We were able to create very well-defined thicker structures with the gelatin by controlling temperature because it's a thermogelling material. So we found actually the optimal temperature that allowed us to print and maintain that structure after printing so that it doesn't just puddle up into a pool or you can't maintain the pores if they start to merge together.
Restoring fertility to a mouse using gelatin in a 3D printer is a true breakthrough. Can this technology someday be used to help people?
Oh, yeah, absolutely. That's our ultimate goal. It's an advancement in this field, not just in tissue engineering and 3D printing, but also in the field of fertility preservation. And it really can lead to a new solution for surviving cancer patients, especially pediatric patients who want to maintain their ability to have normal hormone function as well as give birth to children later after surviving cancer.
Another example is the 3D printing of electronics.
This is Terry Wohlers again. It's his job to predict trends and to stay on the cutting edge of 3D printing applications.
Imagine if you could 3D print electronics that conform to the shape of the product so that you don't have to design the product around a printed circuit board, but vice versa. You can, if it needs to be an ergonomic device, then you could 3D print the electronics around corners and inside the shape of the product.
So what is on the horizon for 3D printing? What is the future?
The next frontier is using the technology for actual manufacturing. So they aren't ignoring or they're not certainly not stopping the use of the technology for prototyping and related applications, but they're investing a great amount of energy and money into developing these machines and materials for actual production.
So what are the benefits of using 3D printing for production and manufacturing?
In some ways, it's so obvious to myself and others as to the benefits of this technology, but it's still relatively expensive, compared to conventional forms of manufacturing. If you're producing a lot of plastic parts, it's difficult to compete with injection molding in the sense of producing a simple part, and then making thousands or millions of it. But what this offers is the fact that you don't have to produce something in thousands of millions to make it feasible. You can produce it in much lower quantities, and you can print them on demand. So rather than trying to forecast that you're going to sell 500,000 of something, and then you do go through all the expense of tooling, and then find out there's only an appetite for 100,000. What do you do with the other 400,000? With this, you can have digital inventories, and you can manufacture on demand. And companies are beginning to see that and trying to understand how their company can benefit from that. And so what's so exciting now is to watch companies, some of the biggest corporations and brands in the world, now beginning to embrace it and really put together teams at the executive level to understand, how they can adopt the technology and benefit from it and ride this next wave of manufacturing.
As Chuck Hull worked nights and weekends on his stereolithography apparatus, could he have anticipated shape-conformable electronics? Or 3D printed liver tissue created by companies like Organovo, based in California? Or the astounding number of companies like GE or Airbus or Lima Corporate in Italy, producing metal parts that are going into aircraft and into human bodies in the form of orthopedic implants and dental crowns and bridges? Or the home and office accessories? Or certainly, toasters?
Oh, for sure, it exceeded the expectations. The application was prototyping of plastic parts, and I commercialized the technology a few years after that, and that was the first application. It was pretty well received with plastic part designers and mechanical engineers and so forth. But right away, as people worked with the technology, they started envisioning other applications well beyond what I had initially thought of. These days anymore, there's hundreds of applications in really diverse fields that there was no way to anticipate back then.
3D printing is certainly taking off and helping people in all walks of life. Do you take a certain level of pride in where 3D printing is going?
I think maybe pride, or just, kind of like you're a father or something and your child is off doing all these things. It's amazing. I think I heard somebody characterize it recently as an avalanche, of technology and ideas. So it's really taking off.
This has been an episode of Here's an Idea, I'm Billy Hurley for Tech Briefs Media. For more news about innovative technologies, you can follow our stories every day at techbriefs.com. Here's an idea. Send us feedback to feedback@techbriefs.com and let us know what inventions you'd like to hear more about.